And welcome all, it's Mr. Callan here to help you with greatest common factors, not just of numbers, but also with algebraic expressions. This is Chapter 5, Lesson 6. We'll call this Part A of Chapter 5, Lesson 6. Before we go on, go ahead and pause your video, whatever this assignment number is, check your answers, and come on back when you're ready. All right, so for today, we're going to take it one step at a time. Our goal, our objective, is to find the greatest common factor of an expression, not just of a number, where before we would just look at two numbers. Maybe we have a fraction and we want to find the greatest common factor to reduce that fraction by. Now we're going to get into algebraic expressions, both with coefficients, the numbers out in front, as well as with variables. We're going to take all our skills, prime factorization, what we know about fractions, and we're going to use it for the algebraic expressions. Sooner or later, we're going to need this, maybe more in Algebra 1, to either simplify algebraic expressions or compute algebraic expressions. Today, just greatest common factor. Tomorrow, you know what that means is coming tomorrow. Pause your video if you'd like. Write down page 133, 13 to 22, 31 to 38. Come on back when you're ready. All right, a reminder of some vocabulary. A factor, ladies and gentlemen, is any number that is multiplied by another number. Well, let's be a little better about that. We'll call this an integer that is multiplied by another number to get another integer. Prime numbers, we've talked about this. Prime numbers are a whole number with exactly two factors, one in itself. So 3 is prime because we have 1 times 3. 5 is prime, 1 times 5. 6 is not prime, 6 is composite because not only does it have 1 times 6, it also has 2 times 3. It has more than two factors. All right. Now, when we would in the past ask to find the greatest common factor of two whole numbers, we might list out all the factors. We might identify any factor that's in common, and then identify the greatest factor that's in common. Now, that's all fine and dandy if you got small numbers like, say, 24 and 30, but what if you have 124 and 330, or it goes into the thousands or the millions? It gets a lot more challenging to identify the common factors by listing them all out. It'd take quite a long time. The good news is there is a more efficient method. All right, so what I'm going to do, I'm going to use upside down division to find the prime factorization of both 36 and 48. Now, just a reminder, we always put 2, 3, 5. We took a list of the first few primes to check each. Now, I know 2 goes into 36 because it's even, and 2 goes into 36 18 times. Meanwhile, 18 is also even, but 9 is not. All right, so now that 2 is done, we try 3, and yes, we see that 3 goes into 9, and we have now identified all prime factors of 36. So I'm going to go ahead, I'm going to expand that out, 2 times 2 times 3 times 3. Now let's do the same thing with 48, because 48 is even, 2 goes into it, 24 is even, 2 goes into that, 12 is even, 2 goes into that, 6 is even, 2 goes into that, and we have now identified the prime factorization of 48, which would be 2 times 2 times 2 times 2 times 3. Notice I'm not going to use power form because to find the greatest common factor of these two numbers, we should identify all numbers that are shared in common. And because they both share a 2 and a 2 and a 3, multiply those common factors out. 2 times 2 is 4. 4 times 3 is 12. So ladies and gents, the greatest common factor of those two numbers is 12. If you think about it, 48 would split down into 4 times 12. 36 would split down into 3 times 12. And while they both share a 12, they don't share anything else in common. We have a 3 on one side, we have a 2 and a 2 on another, or a 4. So to find the greatest common factor of two numbers, or an algebraic expression, you can expand out both numbers prime factorization, circle everything that's in common, and multiply that out and find the product. Now I'm going to go into one more example. Perhaps at any time you can pause, rewind, go back. What we're going to do is we're going to identify the prime factorization of 24, 56, and 72. Don't forget at any time you can make the list of the first several prime factors. That will help guide you through your breaking it down. 24, 2, 2, 2 again, and then we get to 3. Those are all prime. I'm going to stop circling them at some point. 2 times 2 times 2 times 3. And just a reminder that anytime you can actually multiply out to check your prime factorization. 2 times 2 is 4. 4 times 2 is 8. And yes, 8 times 3 is in fact 24. All right, onward we go. 56 can break down. At this time, you can even fast forward the video if you're so comfortable with this. So now we get a prime factorization of 2 times 2 times 2 times 7. And 72 breaks down evenly by 2 and 2 again and 2 again. But 2 doesn't go into 9. 3 does. And there we have all the prime factors of 72. 2 times 2 times 2 times 2. Nope, just kidding. 2 times 2 times 2 times 3 times 3. Now what's important here, because we have 3 numbers to identify, the greatest common factor, it's got to be common to all of them. So for instance, they share a 2, another 2, and another 2. Now you might be tempted to identify a 3 and a 3, but that does not work for greatest common factor because 56 does not have a 3 into it. Therefore, the factors in common, 2 times 2 times 2, or 8. I was hoping that was disappearing ink, but apparently not. So let's get rid of it. Now, if you don't believe it, come back to 24. 24 breaks down into 8 times 3, 56. 56 breaks down into 8 times 7. 72 breaks down into 8 times 9. Now, let's say you accidentally identified those 3's as a common factor. Then you would say 2 times 2 times 2 times 3, which is 24. But please notice, 56, ladies and gents, does not break down into 24. Thus verifying that the number has to be in common with all 3 of the given numbers, given algebraic terms or numbers, whatever is given to you. All right, let's do one more of those. Pause, rewind if you need to. Nope, let's actually get into the algebraic stuff. So the idea is the same. We're going to break both of these down into their prime factorizations, noticing that 10 breaks down into 2 times 5. Then we have an r to the third power. Remember, when you're doing an algebraic factorization, you write out all the r's, not in power form. And we do have a single s. Not that you have to write the 1, but there is an s right there. Write that a little bigger. 15 breaks down 3 times 5 times r times s times s. Now, what factors are held in common? They both have a 5, they both have an r, they both have another r, and they both have an s. Therefore, the prime factorization of these two algebraic expressions, 5 times r times s, or that could be rewritten now, 5r squared s. That is the greatest factor, or should I say factors, held in common by both of those algebraic expressions. If you really wanted to, you could say 10r to the third s would be 5r squared s times another 2 times another r. And we could have done the same thing with 15 r squared s squared. The greatest common factor, 5r squared s times another 3 times another s. But you see that both of these have a common factor, in fact, the greatest common factor of 5r to the second times s. Let's go on, please. 3 terms here. First, I'm going to do 25AB, which can be rewritten as 5 times A times B. 15, we just did 15 is 3 times 5 times A times B. And 10, we just did a 10, 2 times 5 times A times C. Now, be very careful as you're circling things here. They all share a 5. They all share an A. I almost tried to identify, so hopefully that's my disappearing ink. I almost tried to identify another A, except there's no other A in that first term, and therefore, the greatest common factor of all these algebraic expressions is merely a 5A. And ladies and gents, that's really all I have for today. If you'd like to rewind, rewatch the video, bring some questions. Again, the assignment for this lesson is page 133. Only numbers 13 to 22 and 31 to 38. We'll get to other problems, particularly least common multiple, next lesson. All right, thanks folks. Do well, let's grow, and take care of you now. We'll see you.